Thank you for the introduction. I'm Horibe from G-QuAT. The title of my speech is Industrial Level Quantum Computing Solutions. But when I say solutions, you may think about use cases and applications. However, in computing, at the industrial level, if you are trying to deliver solutions, hardware and HPC hybrid is needed. So how to create computation infrastructure is a question that has to be explored. So and also what's user friendly needs to be developed, otherwise it's not going to be a solution. So how computing resource should be delivered to users is an important perspective. So from that kind of perspective, we are thinking about the quantum computing solutions from a broad perspective. Firstly, before that, let me start with a background. Quantum industry strategy. In Japan, this is a quantum strategy in Japan. In the other room, the official from the METI is speaking about the relevant topic. And firstly, before going to the industrial strategy, so the researchers first go to find these material, and by 2040, about 850 billion US dollars or so of a market is expected to be generated. And about 80% are generated by users. So computing resources generate value when there is a use cases, and the same goes for quantum computers. Important thing is to create use cases. Our current understanding is that around 2019, or technically speaking, in January 2020, the first quantum strategy came out in Japan together with roadmap. At that time, it was said that in 2030, 1,000 physical bit will be delivered around 2030, according to the roadmap, and 50 logical bits will be delivered by 2040. Against this kind of background, the governments have been working on various initiatives. However, especially since the end of last year, you might have seen media reporting, but recently, the last 5 years, the R&D has gained momentum, as you see here, and I'd like to use this schedule to speak more about that. And the quantum strategy, which I talked about, was released in January 2020. What happened back then was in 2019, IBM released 27 qubits. Then in 2021, at Kawasaki, it landed Kawasaki, or it was the first landing in Japan. And over these 2 years, IBM machine is symbolic, but AWS, Google, Microsoft, those firms, by going through clouds, created environments where users can access quantum computing, so industrialization had to be considered. So as Japan's strategy or future quantum social vision was established. And based upon such vision, in April last year, the strategy was formulated to create a future based upon quantum computing. So how to deploy quantum technology in society was depicted in the roadmap announced. And as part of this strategy, in order to create an industry, not only the financial support to projects, but also the functionalities are needed to support the industry. And in that background, G-QuAT was established. And after that, the most drastic change happened at the end of last year. You might have heard but for example, IBM, one chip exceeding 1,000 quantum bit. Such processor was developed by IBM, and quantum chip with 133 quantum bits was released as well. And from here, or at the same time, here are computing in the USA. In physical qubit, they conducted demonstration. So as mentioned, logical qubit of 1000 qubit is expected around 2030. And as for logical qubit, 50 logical qubit is expected to be delivered around 2040. That was what was talked about. But at the end of last year, the great progress was made. So industrialization is now needed more than ever before. And IBM quantum utility is a term they use. And they are conducting research not on the quantum computing itself, but quantum computers are positioned as tools for them to conduct R&D. And based on such thinking, various quantum computing startups came to the market. And in July 2024, the superconductivity ion trap and type approaches are now being used. And various things will be made accessible in the near-term future. And quantum computers, by being used with users using quantum computers of various types, how to differentiate the use of different types of quantum computing technologies and what are the benefits of each, and those things have to be determined. So users are going to play key roles in the days ahead. I'm skipping this page. After this, well, due to time constraint, I will be skipping some details, but most important thing is use case, as you see here. These are included in the strategy I touched upon. Also, if we are to create the quantum computers that are usable, then we have to switch from the laboratory-based development to the future or concept where the same things have to be created as tools. Then ability to procure components will be needed, and then the cost could go up as more components are used. Then the quality may be high, but the cost may be so high, 10 million yen per hour. If that is the cost, then it's not usable, it's not affordable. So what's being considered right now is the break-even point perspective. Also, hardware and applications have to come hand in hand as development proceeds. And that's the ecosystem that enables an advanced level of development. So Japan depicted such components in its strategy, and other countries followed in the footstep of Japan, and things are accelerating around the world. And now, what kind of support are we expecting to deliver? When we think about business, so from global perspective, R&D needs to be conducted. So from that kind of perspective, International Advisory Board has been established at our organization to identify what parts or areas needs to be supported. And as we provide support, there are various areas from system design and computer foundation. So we are conducting a full stack initiatives. The benefit of that is the users who are developing applications, they use computers. Then computer usability and performance will have their own limitations, which will be identified. Then from cloud side, algorithm applications are going to be developed on the cloud side. And since next generation computers are going to be needed, so quantum chip development is needed as well. components relevant will have to be developed as well. So at the highest level, there are requirements of users, and that trickle down to the lower levels. And conduct such initiatives, two people from Japan and others from other countries have joined the advisory board. So what's needed is the usable quantum computers. So the central initiatives of us is development of applications. To realize application development, we need the calculation infrastructure, and in the future, more advanced quantum computer needs to be developed. So such hardware design and components enhancement have to be delivered and then evaluated, and then quantum chips have to be improved in terms of yield. Also at each layer. So we cannot do everything on ourselves. So when we think about industrialization, we have to work with corporations and companies in R&D, and the outcome needs to be deployed to businesses. So including existing areas, we have to work with researchers and engineers, and through such initiatives, we are going through such initiatives. That's a plan. And as platform, hardware have to be evaluated, and then computation infrastructure needs to be put in place. So as platform, these things are now being put into operation. I'm skipping this page, and to develop use cases, what kind of computation infrastructure is needed? At our organization, well, since there are only limited number of quantum computers with limited performance, so simulator is playing key role in development. So large-size GPU clusters have been prepared. NVIDIA H100 chips, 2200 chips have been accumulated in the GPU machine, where through collaboration with various people, we are implementing and deploying various functions, and we've decided to introduce two quantum computers, one from the US firm and the other from Fujitsu, the superconductivity quantum computer, which is the fourth in Japan, but it's the first quantum computer that's in the commercial use around the world. And we are having dialogue with various stakeholders, but ion trap type and optical ion type. So those different types of quantum computers are now scheduled to be launched in our ecosystem. By connecting them to a high-speed network, we are looking to create hybrid environment and to deliver to users so that they can communicate with hardware vendors. Their users come to this kind of open space so they can collaborate, and also hardware vendors to develop next generation system. They collaborate with the overseas suppliers as well at this space that we are constructing right now. I'm skipping this page.
もう一つ重要な
Another important aspect is accessibility. Whether it's quantum or classic, the user should not have to distinguish between the two when they use computing power. If you make a special platform, resources developed there would not be applicable to other environments. So basically, we want to use open source. And rather than introducing something that's in development, we want to implement off-the-shelf product or something that will be launched soon. So highlighted in red, you can see Japanese company and Japanese technology related items. And also overseas, we have press release with NVIDIA, CUDA-Q solution by NVIDIA, and also simulation will be used, and the Cura hardware will also be connected to this. So if you access the platform, you can access all the computational resources in one stop. This is the thinking. How to use quantum computing? And we have to think about solutions to be used as well. But end users will have to implement in industry, so we have to identify the real problems of real industries. AIST structure is shown on this slide, and we have, in fact, the 7 research areas: energy, life science, bio, materials, so on and so forth. And in these different research areas, we are also looking into computing and data science. And these researchers are already connected with vertical industry personnel who will be the end users. In that sense, we know what the valuable problems are for us to solve. And we can provide the computational resources that I stated earlier to these people, and where will quantum algorithm and quantum computing use can be figured out by the actual end users. And once the solution is designed, then we can start providing that to the actual related industries, relevant industries. This is how quantum technology can be socially implemented. The quickest path is going through the end user when we figure out the solution. We are strongly promoting material informatics and bioinformatics. Although not listed here, we are also looking into financial services sector. Transportation, in that sense, we are looking at the electro manufacturing in order to optimize the factory operations. And going forward, we want to focus on soil information. We have a lot of soil-related information, so geological information. We can predict disasters. We can identify optimal places for producing specific agricultural produce. When application is developed, there are certain important aspects as well. This is the SIP program in Japan, and this is used as a set of indices. Maturity of technology, TRL, is usually the main focus for technological development, but the economical sense or social importance is important as well for social implementation, so that's BRL and GRL. And these are the aspects that we must not neglect. What's really interesting is if you try to optimize the utility network, for example, the structure of the network for a country like long from north to south versus the United States, which is basically vast, the network structure will be completely different. So if we develop network optimization solution in Japan and try to bring it to the US, it will not work. We have to take into account the geographical characteristics and also in terms of ROI, how likely is it that we can get the return and exactly when. These are the aspects that need to be taken into account. If you just focus on developing the quantum computing and studying it, you may end up with an area with a very small demand, at least at that time. So target demand, target geography, for example, will have to be carefully considered, and solutions should be developed with a level priority. And this is not really limited to quantum computing. This is done in all of the areas of development. The more advanced the technology is, the less people think about this aspect, so you end up with a great technology that will not be implemented. So this was a main message of my presentation. So this is why we want to engage in discussions, dialogues with those of you in the audience today. Now, next generation quantum computing. What should be the ideal state? So for superconductivity, this is what it looks like. What we see in laboratory is very simple, as you can see, but as we try to scale this, number of wires will have to be increased, and the refrigerating system will have to be made larger as well. So it doesn't make economic sense, business sense anymore. So we have come up with a new structure like this, and we will be developing necessary parts and components in association to this. And the relevant technologies have already been developed by AIST, and we'll be implementing this. This is something more recent. Now, for evaluation, we are preparing test beds as well. And at system level, we are trying to optimize at system level as well. We want to bring quantum computing from R&D to mass manufacturing. So hardware level and also industry level quantum computing development is what we're focusing right now. I'll skip this slide. So Keysight Technology and IBM are the key partners that we have started collaborating with. I have spoken about applications and also computing, and in the beginning, I have explained why we are working together. We have problems with application development. We want to reflect that to hardware so that we can do a better job of developing next generation hardware, and using that, we want to be able to generate more valuable use cases. And we want to continue to run this cycle, and building an ecosystem is very important for realizing the use of quantum computing in the actual industry. So valuable use cases, this is something that we would like to work with you to develop. I'm sorry that I overran the given time a little bit, but that's all from me. Thank you very much for your kind attention.